Hello guys, in this video we are going to solve Leetcode problem 211, which is design, add and search words data structure. So we need to design a data structure that supports adding new words and finding if a string matches any previously added string. Okay, so we basically need to implement this word dictionary. Word dictionary initialize the object, add words to the data structure. It can be matched later, and this function search returns true if there is any string in the data structure that matches word, or false otherwise. Word may contains dots, where dots can be matched with any letter. So this is the catch. So suppose word contain dot, then it can be matched with any letter. So we are given this input, which is a list of words. Now we are given this another list of basically list. Then you can see here for bad it is null because bad is not there. Okay, output is null. Okay, so we basically need to return either true or false. Okay, so false, true, true. So bad is not there, so we get it false. Dot ad, sorry, bad is not there, so we get false. Bad is there. Here it is. Okay, now got it. So here we are basically adding word bad, dad, mad, and when we want to search, then it is we want to search bad, which is false. We want to search bad, which will return true. Dot ad, it will also return true because dot can be matched with any character, and b dot dot with it will return true because dot dot can be matched with any character. So I think this input is not of any use. Okay, I think this input is basically first three is for addWord. So these three are for addwords, and these four are for search. So basically these four are for search. Okay, so how can we implement this? So we can solve this problem using try data structure. And when we so in the try data structure we have a node which will have the ch, children and word, and uh, add word is similar to the try data structure, but when we want to search word, then we need to keep in mind that word may contain dot, where dots can be matched with any letter. So in that case we will use DFS, so we can iterate over uh, all the child values and use recursion to solve this problem. Okay, so let's write some code. So let's create a node class. It will have a constructor. It will take ch self dot ch is equals to ch self dot children is equals to empty list self dot word is set to none. Now let's implement here. So self dot root is equals to node of this null. When we want to add word, so let's have current is equals to self dot root. Now for ch in word, if ch not in cur dot children, then basically we will create a node for ch. Children of ch is equals to node of ch. Now uh, children uh, cur is equals to children. Basically we want to move ahead in our try data structure, and at the end cur.word is set to word. Now let's come to the search data structure. So okay, so let's forget about the dot. Okay, now we have cur is equals to self dot root. Now what we want to do, we want to basically for I in range of 0 to length of word. Okay, now there are two possibilities. Either that character is dot, or it is not a dot. So if that character is dot, word of I is equals to dot, then we will implement it. But let's go in the else condition. If it is not a dot, then we need to check if word I is, suppose if word I is not in cur dot children, cur dot children, then we can immediately return false. Otherwise cur is equals to, we will move ahead and it will be word of I. At the end, if all the characters are done, then we can simply return cur dot word. So cur dot word can be either true or false. Okay, so cur dot word is not equals to none. If it is equals to none, then it will return false, otherwise true. Now if it is a dot character, then we basically need to have all the uh, child in cur dot children dot values. And for each child we need to follow this same pattern. So let's have a recursive function. Okay, if dfs of it will be I plus 1 and child is equals to false, so we can return false from here. And let's put this thing in the recursive function dfs. It will take j comma root. Okay, and let's wrap everything inside this. Now dfs of j comma root, so current will be set to root, and for I in range j to length of word, and if word of I is a dot character, then we are basically iterating over each and every child and calling the same recursive function here. if it is not false for the child, then okay, okay. So if it is a true for any of the child, then we can return true. And for any of the child, if it is not true, then at the end we can return false. Okay, so this is our recursive function. Let's run the code and check. Okay, it's a wrong answer. False, 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 and expected is true, true, true. Cool. Then let's do. Okay, got it. So basically, we have not called this recursive function DFS. So let's copy this. Let's call it at the end. Initially, it will start from 0 and it will be a self.root. Run the code. Again, it's a wrong answer. Okay, let me debug it. Return accepted. So we need to basically write this return DFS. We need to call this recursive function and return the value. Submit. So it is accepted. Our code is working fine. Algorithm is working fine. The time complexity of this algorithm is basically order of n because we are iterating the try node only in the one direction only, right? So it's order of n. So I hope you like this video. Please like and subscribe. This code is working fine and it is accepted, as you can see. See you in the next video. Thank you.